In this video, we're going to start our talk about multiplication. We're actually going to do multiplication in 3 different parts because if we did it in one big video, it would be a very long video and I doubt you would want to watch it. So we are going to talk about today 4.5b, 4.4c, and 4.4d. So those are the 3 things that we're going to talk about today. As we start multiplication, the very first thing that we have to do is just do a review of what multiplication is for students. So I may give them a problem. What I like to do at the beginning of the year is I always gave them a multiplication problem, like 6 times 8. And I would have them prove to me that 6 times 8 is 48 any way that they can. And through that, students would give me arrays. Students may give me groups times numbers in each group. Groups may give me factors times factors equal product. Some students may do an area model. Some may break up 8 into 6 and 4 and or 8 into 4 and 4 and do 6 times 4 is 24. But the reason I did this activity was because I wanted to know what students still remembered about multiplication from 3rd grade. They do get introduced to multiplication in 3rd grade formally, and in 3rd grade they work a lot on the multiplication facts, and then they work on solving multiplication problems 2-digit by 1-digit, okay? So students should come to you with a lot of knowledge. So on day 1, I do this sort of activity, and then we talk about the vocabulary. Factor times factor equals product. We talk about this is number of groups times number in each group equals the total number. But we also talk about how this can be reversed. This could say number in each group times number of groups equals the total number. So we talk about that relationship between the factors. It doesn't matter what factor I put first. If I know 6 times 8, I also know 8 times 6. Then, once I do that, I will do some practice with arrays, because we'll go back and re-talk about what arrays are. So I will have students actually build arrays. So I may give them 4 or 2 times 4. And so I'd have them build the array. We would talk about it. We would then take that array and make it into an area model, so that students continue to remember, oh yeah, I remember that last year, and then we'll write it as an equation. Okay, so remember, I can call this 2 times 4 or I can call it 4 times 2. It really doesn't matter. We used to say it mattered whether it was rows times columns or columns times rows. It doesn't matter. They are both the exact same amount. Okay. The only time it matters when we're doing this is when it deals with word problems. When we talk about word problems and we're talking about the contest, it'll matter if we know the number of groups, the number in each group, if we have a total. That'll help us determine what we need to do to solve those word problems. But when I'm just talking about arrays, it doesn't matter whether I say the rows first or the columns first, okay? So I'm going to start out and do some simple things like this. I'm going to make sure this would be a great time. Sorry, here I'm throwing blocks. It would be a great time to do something like this, because one of our TEKs says that we have to teach students about perfect squares. So I may do something like this. It's 3 rows times 3 columns. So I would talk to students about labeling it like this. and what this side would be and this side, and we would go ahead and do that term. It's a perfect square. So that is what I'm going to do first. I'm going to do some review of what they learned last year, make sure I give them that vocabulary. Then I'm going to move into making sure we understand what an array is, an area model is, how to write the equation, and I'm going to introduce those perfect squares. Okay? From there, I am going to start talking to the students about multiplying by 10 and multiplying by 100. Okay? So, what I want you to do is make sure students really have an understanding of what multiplying by 10 and 100 means, not just using any kind of trick or rule or cutesy little saying, okay? So, I'm going to start off slow. And I can even have out a hundreds chart if I want to. Because I'm going to talk to students and say, if I have 4 tens, this is 10 plus 10 plus 10 plus 10, right? It's repeat addition. I have 4 tens. So I have 4 times 10, and I may actually, on the hundreds chart, make them count down with me. 10, 20, 30, 40, okay? So 4 times 10 equals 40. And then I may do another one, 6 times 10. We may do the exact same thing as 60. And then we're going to talk about, well, what are you noticing each time? Every time I multiply by a 10, my product ends in a 0, 1, 0. So we're going to talk about that. Then I can give them something like this. And we can talk about, well, I wonder if it holds true with multiples of 10. So what does this mean? It means 80 plus 80 plus 80 plus 80. But I don't want to do all that. I don't have to add all that together. Okay, so what if I go back to a 10? What if I do this? Okay, what is 4 times 8? It is 32. And then 32 times 10 equals, well, if I have 32 tens and it holds true to this rule, then I know it ends in a 0. So 320 is my answer. Okay? So, I want you to make sure that you are teaching students the actual, or building up some actual understanding with the rule of times 10 times 100. So you're going to do the same thing with 100. You're going to start very small, and then you're going to build up to different hundreds. This is a very important skill because when we get to the area model next, this is going to play a big part in us being able to multiply by multiples of 10 in our area model and when we do division, okay? All right, so then from there, we are going to actually get into multiplying 2, 3, and 4-digit numbers. So we do 2 by 1, we do 3 by 1, we do 4 by 1, and we do 2 by 2. I do not see a reason to separate them at all. I want you to do them all together. They need to see that when I multiply, it doesn't work where I just get 2 by 1, then I get 3 by 1, then I get 4 by 1. Oh, now miraculously we're going to go 2 by 2, and that's all we're trying. I want to vary up the problems for students. When we start this out, this is all teacher-led. The students are working with you through the problems, all right? So, I'm going to start, I'm putting some paper down to give a little background. Let's say I'm going to start with 2 by 1, and I want to do 13 times 4. So what I'm going to do first is I'm going to lay out, because there is a progression to teaching multiplication. And that progression is we start concretely, then we move into the area model, then we move into partial products, and finally we teach using the standard algorithm. We never jump to the standard algorithm. The standard algorithm is the most abstract, okay? So you need to make sure that that is the last one that you teach. All right, so I am doing 13 times 4. So I'm going to show that to my kids. I'm going to make the little array here. Okay, and I can do this to show them that this is what I'm multiplying by. So now I'm going to work it out in between here. Make sure I'm not getting off on my paper. Okay, so I'm going to talk to the kids about, I have a 10 and I have a 1. So what is 10 times 1? It is 10. I have a 10, I have a 1. It's 10 again. I have a 10 times a 1. Oh, I think that's a 9. That must have got in there. I have another 10 times a 1. And then I have 1 times 1, 1 times 1, 1 times 1, 1 times 1. So 1 times 1, 1 times 1, 1 times 1, 1 times 1. The kids don't have to have the blocks, they just need to be able to see you use them so that they can understand how the array fits together with the area model with larger numbers, okay? Because they need to see the pattern that it makes. All right, so if you have magnetic base 10, that's fine. If you have these little ones that we just created, that's fine too. However, you can model this for the students. If you have enough base 10, you want to put them into one, each group has their own set and they're creating it along with you, that's fine too. All right, so from this, we've created our array. This is the actual array here. So we could count and tell you the answer to 13 times 4. It's 10, 20, 30, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52. Now, I want to show students how this relates. I'm going to say, boys and girls, what if I already have this? What if I finished out the rectangle? I have 10 and I have 3 and I have 4 on top. So I have two really sections. I have 10 times 4, which is 40. Is that what I have here? Yes. And then I have 3 times 4, which is 12. And then from there, I can add those two together, and I get 52. Okay? So that is how I want to start off with students. Let's do a 2x2 example. Flip this over. Let's do a 2x2 example. Make sure I'm still on my paper here. Okay. All right. So let's say, and I'm doing smaller numbers so that I can use the blocks effectively. So let's say I'm doing 21 times 14. All right, so I'm going to do the same thing. It's just going to be a little bit bigger this time. So I'm going to take 21, and then I'm going to take 14. All right, and we're going to do the same thing with this one. So let's look. I have a 10 times a 10. That gives me 100. I have a 10 times a 10. That gives me 100. I have a 1 times a 10, that gives me a 10. Okay. Now I have a 10 times a 1, that gives me a 10. 10 times a 1, that gives me a 10. 10 times a 1, 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 a 10. 10 times a 1 again, a 10. Now I have 1 times 1, which is 1. I have 1 times 1, which is 1. 1 times 1, and 1 times 1. Okay? So I can very easily find my answer. It's 100, 200, 10, 120, 130, 140, 150, 160, 170, 180, 190, 194. And then once again, I'm going to talk to the student. So what if I made this into an rectangle? That's what this is, okay? I have a 10, a 10, and a 1. So you can either write it like this, a 10, a 10, and a 1, or you could put these two together and make it a 20. That is what I like to do because I've talked to students about, I have 20, I usually tell them to separate it between the 10s and the 1s. So I have 20 and I have 1. And up here I have 10 and I have 4 1s. So, and this one's going to look a little differently because now I have 4 different sections, and I hope you can see the 4 sections here. 20 times 10. 20 times 10 gives me 100, 200. And this is where multiplying by multiples of 10 will help students understand why I now have 2 zeros here instead of 1. Because both of these are 10s, and when I multiply 10 by 10, I get 100, and 100 always ends in 2 zeros. So that is this section, and if I could do that like this, you'll see those sections. Okay, so then I do 20 times 4. Here's my 20, here's my 4, that is 80. Here's where multiplying by those multiples of 10, or by 10 and 100 help us. Then I have a 1 and a 10, which is a 10. So you can see that right here. And then I have a 1 times a 4, which is a 4. Then I add all these up, and it's up to you. You can have them add it this way or add it to the right. It really doesn't matter. So I have 210. Hope you can see that. Yep. Plus 84. And that gives me 294. Okay, so for the first 5 days of multiplication, this is what you're doing. You're reviewing the multiplication, you're talking about vocabulary, you're teaching them to multiply by 10 and 100 and those multiples of 10s and hundreds, and then you are starting practice with arrays and area models and showing them how they fit together. So you're going to do teacher-led on that, and then you're going to do guided practice and eventually get them to individual partner practice. Be sure to include perfect squares in here. I do want to say that nowhere in our scope and sequence does it talk about doing multiplication facts. We do not directly teach multiplication facts in 4th grade during our whole group math time. I'm not saying students come to you knowing multiplication facts because they do not. So we're going to tackle multiplication facts during number talks with some multiplication number strings. We're going to tackle multiplication facts during our stations. We're going to tackle multiplication facts during homework as well. So it is something that you constantly need to have in your stations. It's something that you constantly need to be practicing or giving them opportunities to practice at homework and stations, and you will direct teach to those number talks. However, it's not something that we're spending time on during whole group time at this point in the year. All right, so long enough video for this time. Thanks for sticking around. The next video will be over the next 6 days of multiplication, which will look at partial products and the standard algorithm.